Yeah, thank you very much. This talk is about 9 mistakes I've done while building network automation. Um, really, because this quote says it all. You guys simply don't have enough time to make all the same mistakes, so let's try to learn from each other. First, I'm Allan Eising. I have worked for about 17 years in this industry, and I work full-time with network automation these days in Telia. And there I'm responsible for network architecture, network automation architecture, and the services we build for Norway specifically, where I also live now. I used to live here in Copenhagen. I was part of founding this wonderful event. If you're curious about what I'm up to, you can try and follow me on these social media things, but I'm not very active there. But my primary claim to fame is that I've made a lot of mistakes. And is that a bad thing? Well, you can make really bad mistakes for sure. You can crash a production network. That's a bad mistake. But usually you can fix your mistakes. You can't necessarily fix your own mistake always. Sometimes you need some help. But most mistakes can be fixed. And it's really my experience in this industry that, well, mistakes are fixable. Temporary solutions are often permanent. So let's head into it. I have 9 mistakes here and some possible solutions to them. And really the first mistake I've done while building network automation is not testing it on real hardware. And why might I have done this? Well, I have virtual routers. Well, and you can get most routers these days as a virtual image. You can load it on your PC, you can load it on your cloud, whatever. But you pretty much quickly discover that these are not exactly the same as hardware. They might have interesting quirks. They might have stuff they don't support. It might be that certain commands just don't exist on them or respond differently than what they do on your production physical hardware routers. So they're really not the same. If you're using some network automation framework like Cisco NSO, for example, there are simulated routers there as well. And these are even worse because they usually don't validate your configuration properly. You can reference all sorts of stuff that doesn't exist. You can point to a prefix list that isn't created. You can configure the same IP address 9 times in the same VRF. It will never complain. So these are not really testing it on proper hardware. So when you actually deploy it in production, maybe it doesn't work. Maybe it fails. Maybe it breaks. Another mistake that I often do is that I think I understand all the details. And that's because I'm a network engineer, right? I've been working with network engineering for so many years that I know what an L3 VPN is. I know how these various parameters are. But maybe there's some things that I don't know. And the worst of it is that I sometimes write my assumptions into my code. And that can lead to some really strange bugs when suddenly I've hard-coded that an MTU can never be less than 1500, for example, and suddenly you need an MTU that's less than 1500 and it doesn't work. Well, you have written your assumption into your code. So let's talk about what you can do in this situation. And with hardware, there's really only one way, and that's getting a lab. And you might try to ask your boss about that, and he might say no because that sounds expensive. But you should really insist on it, and you should get a paper trail. Get this denial in writing. You should laminate it. You should put it into a drawer and keep it safe. Because when things then fail, because eventually it will, you can take your fine piece of paper that you've laminated and show your colleagues that you're really not to blame for this. So don't test in production, or if you don't have a lab, maybe you're forced to do it. So it's very, very good to be mindful about this, to know that you don't have any other choice than to test in production. And in that case, you will have to do it very, very carefully, maybe late at night, find some corner of production that doesn't have that much traffic, where you can actually mess up a little bit and don't disturb your important customers. So maybe you are forced to it, but get a lab. You might have colleagues who are really experts in the stuff you're automating. You should involve them really, really early. You should talk to them as the first thing, understand exactly how things work, so you don't have your own assumptions, but you get your assumptions validated. You should give them time to test your code when you're writing it, and you should, well, they should have a lab too, right? But when you write your your automation, you should try to write it in a way where it's readable what the business logic is here. And business logic can just be just the order of operations here is a good example of it, right? So in the pseudocode I've included here, I'm like configuring a backbone port, so I have functions that do every step of the process, and it's readable that way. So I know then when my IP addresses aren't configured correctly, I can go to the configure IP address function, and then I can fix the logic there. And be humble as well. Don't assume you know better than the experts. The third mistake is something I like to call, or I haven't invented this term, but it's called the golden hammer. And it comes from this saying that if the only tool you have is a hammer, then everything looks like a nail. So it's usually when we're using framework for everything. You might have some system that you've done everything in, and you're using it for everything. Or you have this one big application that you're using for it, or big framework, or whatever it is, and it doesn't really do the thing you want to do anymore, but you are sort of forcing it to do it anyway. Or you have some vendor system that you're paying a lot of money for, and since you're paying that much amount of money, you have to use it, right? And it usually it ends up with very, very complicated solutions, especially when you are forcing systems to be something that they are not. And that's quite a problem. And complexity in general is a mistake that I've done a lot. And a lot of it has to do with network engineering is a complicated field. If it wasn't complicated, we would like cancel out most of this day and just go for beers right away, right? You have a tendency to write this complexity into your code as well, thinking that because you know it's so complicated, your code is also very, very complicated, right? And you might have like a system that suddenly needs to do 10 different things, and you're writing these workflows into one application, and it just goes out of hand. Or you have a corner case in your services, something really, really complicated that, well, isn't very common, but it's still complicated, and suddenly it's the majority of your code that's just handling this one corner case. And suddenly your colleagues are avoiding you at lunch. So first of all, you need to identify, especially in the case of the golden hammer, where it comes from. Who are forcing you to work in a certain way? Is it your manager who's forcing you to use a product that your company's paid millions for? Or do you have a senior customer who forces you to work a certain way because that's the way he's done for 10 years? And damn it, if we are changing our ways now. Or is it you? Are you always reaching for the same solution because that's what you're used to doing? It's very, very important to be mindful about this. So you should explore new ways of doing things if you have the opportunity for it. And a great way to do that is to come to events like DKNOG and talk to your colleagues and your industry peers and figure out how they're solving their solutions. And if you find out that your code looks complicated, you should refactor it, and you should do that early and often. And a good way to sort of gauge that is if you haven't looked at your code for half a year and you open it up and you have no idea what's going on, that's a good time to refactor it. And you can try to make it into smaller, less complicated components and try to fit it together with some external tool that'll call them in order. But most importantly, have a test suite. Have something that will actually tell you once you started rewriting your code, is it still working? Or have you broken some functionality that was there before? That's really the key to better refactoring. This one, I think, will probably seem familiar to a lot of people in this room. I hope so, at least. Because this is when you've uniquely, as a person, identified something that needs to be fixed. And nobody else has seen this, and certainly nobody else has tried to do something about it. So you sit and you write your own little application that solves something, and now it's part of production. And you might be working as a regular network engineer. You're not a developer. So you've spent a good deal of your spare time, your weekends, writing this thing. And suddenly it breaks because you've spent your spare time on it. You're not a developer and you're doing it alone. So you're sitting there alone trying to fix something that's broken, and you might not even be able to. And code quality is a part of the previous problem, but it's also a problem in itself, because you might be working on an application stack or an automation system that wasn't intended to be very large, but suddenly it has become very large. And now it just fails all the time, randomly. And when things grow to a certain size where they start to fail because of scaling issues, the errors won't be very informative, and the end users will certainly not understand what to do in that situation. But if you've written it with a poor code quality, it might be very hard to get your colleagues' help here. Or maybe it's not necessarily the quality of the code itself, but the way it's structured. So nobody really seems to be able to follow the code, and you become protective of your code, and you won't let anybody else do something with your code because only you know how it works, and if anybody else touches my code, it will break. So here's some ways you can look at this. First of all, really try to avoid writing business critical software alone. I really mean this. Is this familiar to anybody here in the room? Have you done things like that? No, I can't imagine. But try not to do that. Try to have a team around you if you can. And certainly don't try to write it in your spare time. Because, I mean, it's cool to come into work and sort of show off this cool thing you made in your spare time and be the man of the hour for a little while. People kind of forget the stuff you made and that you made it in your spare time, and especially when it starts breaking, that sort of gratitude is just gone. So try instead to sell the idea to your colleagues or to your manager, and try to get some time allocated to actually do it. And especially that thing with your manager, make sure that your manager is on board with it and is your ally in this process, because it's your manager that you can refer to if you're suddenly called at 3 a.m. in the morning while you are on your holiday in Gran Canaria in your swimming trunks, and weren't really wanting to support that one application you wrote a while back. So make your manager your friend here. And when writing code, and this is regardless of you're working on it alone or you're working in a team, there's a lot of ways that you can help yourself writing better code. There are tools that can tell you if you've done mistakes. There are ways to format your code to a certain standard. There are frameworks to write tests in. And if you're really unsure about how any of this works, there's something called a code style guide, which I will really recommend you to look up. Basically, it's a guide on how to format your code and which choices to make along the way. There's several available. There are to many different programming languages. I have some links that'll show up in a second if you're writing in Python, but if you're writing in anything else, there's probably a style guide out there that you can read. And you don't have to agree with it 100%, but look at it. Somebody has thought about how to do this. You should also hold code reviews, especially if you're in a team. If you're a solo project, it doesn't make any sense. But if you're in a team, have somebody read your code before it merges into production. And really listen to their feedback, force them to read it, actually. Here's some links. If you download my slides, you'll get it. These links as well. But Google's Python style guide I can really recommend. And there's some other links here. Language servers are a relatively new thing. You can put something into your editor that actually reads your code and understands how things are fitting together and allows you to refactor things easily. On the subject of testing, here's a mistake I've done. Writing automatic tests that actually don't test anything realistically. Because I've made up some test data, and it's test data that I've made up, and I also wrote the code, so I know what works, so I'll just put in whatever works, right? And it's very easy to make tests that run one at a time, but that means you never really test things in combinations. And you might integrate with a system like an IPAM system, for example. You're fetching IP addresses from your automation. You might not have that system on your laptop, so you use a mock API to call that system. And that's not necessarily a mistake, but it can lead to things not working when it's actually subject to real-world data. Because those systems might not respond the way you thought they were, or according to that specification. So some things you can consider here: have an environment where you actually test these integrations, preferably also with a lab attached to it. That would be cool. And that environment really needs to have a copy of all the systems that talk with your systems and all the systems your systems talk to, so you can actually test if it works. And when you have a system, you should actually talk to your users and hear how they're using your tools. They might not use it the same way that you thought it would be used. So you should try to replicate those behaviors in your tests. And you should also get the data that you're using, like production data. You might want to sort of obfuscate it a little bit for anonymity, but try to base your test off something that's close as possible to actual real life data. And you should also test everything in combination. So, how am I on time? Plenty. I've been talking really fast then. I have 20 minutes. Excellent. Wow, I'm nearly, yeah. So I've been talking really fast. I tested this a couple of weeks ago, and it was 30 minutes to the second. So I must have been talking a lot slower than I am right now. So we can just delve a little with the users here. We can, because you should really listen to your users. And I think it's really important to get their perspective on it. And it's really easy for you as sort of the architect of a system to say, I built this thing, right? I know exactly how it's supposed to be used. So my users, they just have to accept that there is only one way to use it. That's the way that I figured out, right? And then you might wonder, as the next thing, why are they not reading my mind? And why are they not reading all that documentation that I wrote for them, right? And you just have to accept that documentation is something that is a little bit optional. I mean, it's good that you write it, and you must absolutely write it, but your users cannot be expected to actually read it. Especially you can be 100% certain if your application is of a certain size. There will be one user who will never read the documentation and also never read the warnings. So that user will most likely break everything at least once, or maybe at a regular basis. But what's really important here is that user is probably going to be your most important user, and it's certainly your most important tester. So you should really try to sit down with that user and actually, well, maybe give them the beta copy of your application before you head into production with it, or at least understand what they're trying to do, and maybe just put that into a test or two as well. It's very important when you do any sort of network-facing automation that there is a way to roll back. There is a way to revert the stuff that broke when your user didn't read the warnings, or just because you made a bug. That might also be the case. Or maybe just somebody typoed something. There needs to be a way to revert your changes, and you also need to log all the interaction, at least so you know what has been done and by whom. Your users will not necessarily contact you with other than complaints. Your users might have a lot of ideas, but think you're too busy to listen to their ideas. So try to organize something where you actually talk to the users in a sort of more structured way, where it's not just about them complaining about something that isn't working as they thought it would, or bugs or whatever, but something where you can actually talk constructively around how to use automation. Because users, especially network engineering users, they will do the automation for you. We will do our own automation if the systems don't exist, and you want to avoid them becoming the lone cowboys themselves. You actually want to listen to what they are needing in their everyday life and see if that actually fits in with your own plans as well. When you do documentation, consider also doing something in a video form as well, because people will put that on, and at least they will pay attention to half of it, whereas the documentation might not even read some of it at all. We've been living through a pandemic now, and we've been doing everything over Teams chat or video conferences. But for training, I would really recommend you to actually go ahead and do that in person, if at all possible. People will ask more questions there. There are people who will never ask questions at all on video trainings. They will just shut their webcam off and take a nap and then come back afterwards, or so it will feel to you. So classroom training is really the thing to do. and I think I will be done very soon with this. But my final mistake here is not making mistakes, and I think that's probably my main message to you tonight is that if you don't take risk, you won't achieve very much. So take risk. So don't be afraid of failing, but and don't worry too much about failing to even start. And don't overthink your solutions. That's something I tend to do very much. And sometimes I'll never finish anything because I'm just overthinking the complexity here. I think a lot of us are guilty of that. I think that's a thing you end up getting very used to in this industry. Or maybe you've just read this slideshow and you've sort of blinked out a couple of times and missed the part where I tried to come up with solutions. Or maybe you just were overwhelmed on how quickly I went through this presentation. So when you start on a project, whether it's your own solo project or it's a big thing, try to figure out what is the minimum amount of functionality I can get away with building and still call it a success. And it might be much less than you actually think it is. It might be, the simplest iteration of the simplest customer service you have, and that's just good enough. Get that out, get that in production, and then you can start building the complexity on top of it. If you just think about how you are going to test your solution before you start actually doing anything, then you're a good way already. Then you don't have to have fully written tests from day one, but just as long as you consider how is this going to be tested, who are going to test this, is it good enough that I install these virtual routers, or can I get a lab now? Do we have a lab? Do we have some old hardware I can use? Something like that. Think about that from the beginning. And one of the ways you can sort of overcome this periodization you can get from overcomplicating things and from being afraid of really delivering because you're afraid of all the consequences, the failures, or the complexity, is try to make yourself accountable here. And that could be like trying to promise somebody that you're doing it, or trying to come up with a timeline, like I'm gonna do this thing and I'm gonna be done in about 3 months' time. It's easier to say, well, I got delayed, but I'm still on track, rather than just to sit with it yourself and nobody knows that you're going to deliver it. So you will eventually be in a situation where it doesn't really matter too much. You're too far behind, and you didn't find the time anyway. So and nobody's expecting it from you, so you won't deliver it. Make yourself accountable, then people will hold you accountable. And allow yourself to fail is important. If you know about the ways it can fail and keep these failures I've listed here in mind, you will have a safe way of failing because you have already thought about lab testing. You've already thought about how your code is supposed to be structured. So your failures are sort of anticipated, or you can anticipate in the general direction you'll be failing, and you'll certainly learn from it no matter what. Important again, go to NOG events, go and talk to your colleagues, let's talk during the social tonight. Let's exchange war stories, times where everything failed, and let's celebrate all those failures and try to get something positive out of them. And do also yourself tell about your mistakes at NOG events, like I'm doing here, because that's really the only way we get moving forward with this. We need to learn from each other's failures and learn that it's not dangerous to do so. I thought I would be completely out of time by this, but maybe there's some comments or questions.
So we are actually 10 minutes ahead, so it's perfect.
Yeah.
So you have 10 minutes for questions. Well, I think there's one.
Hi, Wilhelm from Via Europa. I was a bit curious about the testing part with you that you were underlining a lot, and I was wondering if you could talk a bit about like how do you do your testing and so on, because I find it a bit hard to make myself least?
Yep, absolutely. So there's a lot of terminology around testing. I think the one I find the easiest to talk about is the integration testing, scenario testing we do, which is basically where we run a service workflow through. Like we will load our test environment out with a simple topology, and then we configure the services we want to test, and we get the output from those services, and we compare that to a known good one. I think that's the simplest approach to it. We are a heavy Cisco NSO users, so we obviously use Cisco NSO for our testing, but it's not so important actually. We're using something called the robot framework for our tests, which is a general testing framework where you can write keywords and all that. So we've written keywords to load a service, to get the service output, and to do various like updates and deletions and things like that in it. So any framework that allows you to run steps in order will do, basically. And it doesn't have to be more complicated than producing an output and comparing that output to something you know is good.
Tom Klaffler, first of all, thank you for that talk. It's always good to see people talk a bit more about like software engineering excellence in a networking conference, so thanks for that. Regarding your comment about like testing in production, I would advise everyone to test in production frequently and often. For one reason is that production will always break whatever it is that you test. It has that very annoying tendency of doing the one thing that you didn't expect it to. That's one thing. The second thing is it makes you very aware of your blast radius. It's a good example. We deployed automation ages ago. Everything worked fine in testing, hit it in production, and 24 hours later, I was no longer able to SSH into a single control plane of any of the switches. These things don't show up in testing, right? This is only a thing that shows up after 24 hours in production. So test it frequently, test it often, and then you see what the blast radius is, and then you can adjust accordingly.
Yeah, that's a very good comment. Thank you for that. Yeah, I think it comes down to also talking with the users, because eventually they'll try something that you really haven't thought about, and you can take that back with you to your own tests, but they will show up in production before they show up in your own tests. Oh.
Thank you. Jan Perry from Forskningsnettet. Some of you might work places where they have a real development department, and they have, of course, everything set up for making a project, describing a project, and doing some code, doing some colleague help, and especially saving the source code. Some of us do it, as you said, some late nights on our home computer, and then we just bring the compiled code or something like that to the office. And when things happen after half a year, then we never know where the source code is. Do you have any good suggestions to what should be done, at least to be able to do some decent rework?
Yeah, it's complicated because I think it varies on where you're employed, right? If you're employed at a university, for example, then it might not be a problem to open source your application. If you work for Jeff Bezos, then it's probably harder to open source your application, I imagine. So it really depends. You could ask your development department if they have something you could use, because usually they have, like everybody's using JIT these days, so maybe they have their own GitLab instance or whatever it is. But there's a lot of tools that are easy to install in that regard. But I would also advise you not to write too many software projects at home and bring the compiled code back to work the day after, because that sounds like a problem in many other ways.
Morten, I'm a CTO from SmartShare Systems. We develop network products, appliances, virtual appliances. So I'm basically a software guy. What you said about errors occurring only in production, that happens especially if you do something in volume and you test it, and then there's always some customer that does something weird or extreme, and then errors occur. Some of the things we do, if we have the time for it in the roadmap, if we envision a feature in some future version, we try in earlier versions to collect information like debug logs and so on, that we can use to determine how would that feature behave. So it's a kind of preemptive use of debug logging. So we try to collect information that we can use later on. So that's also a tip.
Yeah, that's a very good tip. I think it's hard to think concrete on how to use that in network automation specifically. I think that applies a lot more to an appliance than network automation in the broad sense, but I think it's a very good tip.
We almost filled all the 10 minutes. We are at 8 minutes now. So we still have a couple. Where you go?
So my name is Lars Berger. I'm a consultant working for Telia. I have a question about your magic hammer, the golden hammer.
Yep.
And you said you were an NSO user.
All of these mistakes are things I have done.
So, but how? I mean, this is a very dangerous. Oh, this is a very dangerous situation when your entire framework is built up around a single vendor tool.
Yeah.
Because that's complete buy-in.
Yeah. You're absolutely right.
But you listed as a mistake and we can overcome mistakes. But I feel like this is one of those you sort of.
Yeah. Well. Not all mistakes are easily solvable. Let's put it like that. But it is possible to work around it. I can't go too much into detail, but one of the things I would suggest is if you find yourself walking into that area, try to see if you can put a small layer in between you and the end users, like some small API gateway thing. Even if it's just proxying everything that comes in, at least that allows you to, in the future, put more functionality in it, so you can redirect to another application you have. So you're not. So you don't necessarily have to rewrite your whole API, but you might have to, and that's the kind of direction I'm looking currently. But again, it's extremely hard. As soon as you've first gone into this direction, you're kind of stuck.
Okay. Yep.
Job Snyder's Fastly. I wanted to contribute a pointer to literature that was published by the RFC editor. On April 1st, 2022, they published RFC 9225, titled Software Defects Considered Harmful. And the document discourages the practice of introducing software defects and clarifies the best current practice in this regard. So, Section 4, Requirement 1 states, authors must not implement bugs. And I think that settles it. So if you're compliant with this RFC.
Thank you very much.
Okay, we reached the end of the slot for the talk. I don't see any other questions coming. I'm calling it. So, well, thank you, Allan. We don't have a chocolate for you for now.
I know where they are.
You'll get it later.